Hello
Hello
everyone,
everyone,
welcome
welcome
back to
back
our
to our
Python
Python
series.
series.
If you
If
have
you have
completed
completed
day
day
8,
8,
then
then
you
you
already
already
know
know
how to
how to
work
work
with
with
list.
list.
Today we
Today
are
we are
moving to
moving to
another
another
very
very
important
important
topic
topic
that is
that is
used in
used in
almost
almost
every
every
Python
Python
project,
project,
tuples,
tuples,
sets
sets
and
and
dictionaries.
dictionaries.
In this
In this
video
video
you will
you will
learn
learn
what are
what are
tuples,
tuples,
how
how
sets
sets
automatically
automatically
remove
remove
duplicate
duplicate
values,
values,
what are
what are
dictionary,
dictionary,
different
different
operations
operations
and
and
useful
useful
built-in
built-in
methods.
methods.
By the
By the
end of
end of
this
this
1
one
hour
hour
session,
session,
you will
you
be
will be
able
able
to
to
choose
choose
the
the
correct
correct
data
data
structure
structure
for
for
different
different
situations
situations
and
and
write
write
clearer,
clearer,
faster,
faster,
and
and
more
more
professional
professional
Python
Python
code.
code.
So,
So
if you
if
are
you are
serious
serious
about
about
learning
learning
Python
Python
from
from
beginner
beginner
to
to
advanced,
advanced,
make
make
sure you
sure you
watch the
watch the
video
video
till the
till the
end.
end.
Practice
Practice
every
every
problem with
problem with
me
me
and
and
don't
don't
skip the
skip the
coding
coding
exercises.
exercises.
If you
If
are
you are
new to
new
the
to the
channel,
channel,
don't
don't
forget to
forget to
like,
like,
share,
share,
subscribe
subscribe
because
because
every
every
day
day
we
we
are
are
covering
covering
one
one
complete
complete
Python
Python
topic
topic
with
with
easy
easy
explanation
explanation
and
and
practical
practical
examples.
examples.
Now,
Now,
without
without
wasting any
wasting any
more
more
time,
time,
let's
let's
start day
start day
9
9
and
and
begin with
begin with
our
our
first
first
topic,
topic,
tuple in
tuple in
Python.
Python. Hello everyone, welcome back to day 9 of our Python Complete series. Before starting today's topic, let's spend the next 3 minutes revising everything we learned in day 9. Day 8. Revision is one of the most and best way to strengthen your programming concept. If you remember yesterday's topic, today's lesson on tuples, sets, dictionaries, and become much easier. Will become much easier. What is a list? In last class, we studied about list. What is a list? A list is one of the Python most commonly used data structures. It allows us to store multiple values inside a single variable. Instead of creating five separate variables, we store everything inside one list. The flexibility makes list extremely useful. Secondly, we study list indexing. Mm, every element in a list has a position called an index. First index is 0, second index is 1, third index is 2. Python always start index from 0, not 1. And third is list slicing. After indexing, we learned slicing. Slicing allows us to extract multiple elements from a list. Remember, starting index is included and ending index is excluded. Then we explored several useful list methods. First is append, adds an element at the end, then insert, removes, adds an element at a specific position, then removes a value, then pop, removes an element using its index, then sorts the list in ascending order, then reverses the order of elements, then copy, creates a duplicate list, and next, nested list. We also learned nested list where one list can contain another list. Nested lists are useful for storing structured data like marks, employee records, and matrices. And then we study list comprehensions. Finally, we learn one of the most Python coolest feature, list comprehension. Instead of writing long loops, we can create list in just one line. This makes our code shorter, cleaner, and more Pythonic. That's a quick revision of everything from day 8. Now that's our concept of list are clear. let's move on to today's first topic and understand tuples in Python, where we will see how they are different from lists and when we should use them. Tuple. Now let's begin today's topic, tuple. In this previous class, we learned about list where we can add, remove, update, and delete elements whenever we want. But in real world programming, there are many situations where data should never be changed after it is created. For example, a person, date of birth, days of week, or month of the year, country's name, mathematical coordinates. These values usually remains fixed for storing such data. Python provides tuples. Definition of tuple is a tuple is an ordered collection of data. Just like a list, a tuple can store numbers, string, boolean values, mixed data types. The biggest difference list and tuple is tuples are immutable. Immutable means once a tuple is created, its data cannot be changed. You cannot add element, remove element, modify existing element. Once created, the tuples remains exactly the same. Think of it like a printed Aadhaar card. You can read it in many times, but you cannot change the printed information. Lists are like notebooks. You can erase and write again. Tuples are like printed certificates. You cannot edit them. Creating a tuple is very simple. We use parentheses instead of square brackets. Example of tuple. When we print this, it will print tuple. Let's understand. Here, Rahul is a name, 20 is a age, Delhi is a city. All three values are stored together inside one tuple. Just like this, tuples can also contain different data types. For example, write here this. This is perfectly valid. If I write print data, then run the code, it will print the data. Now the question is, if tuples cannot be modified, can we still read their values? Absolutely yes. We access tuple elements exactly like list using index numbers. Like I write here color red, green, blue. If I write here print color 0, then run the code, it will print red. If I write print color 2, then run the code, it will print blue. Remember, Python indexing always starts from 0. Then for this tuple, it will red is 0, green is 1, and blue is 2. Python also supports negative indexing. Instead of counting from the beginning, negative indexing the count from the end. Example, I write a print color -1, then run the code, it will print blue. Let's see the indexing. Here, here I am showing you the indexing chart. Positive, this. -1 always represents the last element. Similarly, Colors -2 is green, the output is green. Negative indexing is very useful when you want the last few values without knowing the total size of the tuple. Now, here's very common interview question. How do we create a tuple containing only one element? Many beginners write like this. First comment out this. This is wrong because Python considers it just a normal integer inside parentheses. Let's check here. If I write print type num, it will print class integer. So this is not a tuple. Correct way to create a tuple with one element, always add a comma at the end. Now check its type. The output is tuple. Remember the shortcut. One element tuple equal to value plus comma. The comma makes Python understand that this is a tuple. Now let's prove that tuples cannot be modified. Like I write here number 10, 20, 30, then numbers 1 equal to 50. Then write print number. When we run this program, Python immediately gives an error, type error. You may also see a message like type error, tuple object does not support item assignment. This means Python is saying I cannot change any element inside a tuple because tuples are immutable. Why are tuples immutable? Now many students ask, why did Python create tuple if lists already exist? Good question. There are several reasons. First, data safety. Important data cannot be changed accidentally. For example, days of week, months, country codes, students' roll numbers. This should remain fixed. Faster performance. Since tuples never changes, Python can optimize them. Tuples are generally slightly faster than lists. Less memory. Tuples consume less memory compared to lists. This is useful when working with large number datasets. Reliable data. When multiple programmers work on the same data, using tuples ensure nobody accidentally modifies important values. A tuple is an ordered collection. Tuples are created using parentheses. Elements are accessed using indexing. Negative indexing also works. Now that we understand that what tuples are and why they are useful, let's move to the next topic, learn about tuples operations, where we will see that actions we can still perform on tuples even though they cannot be modified. Now that we understand that tuples are, let's talk about tuples methods. In the previous class, you saw the list have many built-in methods like append, insert, remove, pop, sort, reverse. But tuples are different. Since tuples are immutable, Python does not allow methods to modify them. That's why tuples have only two built-in methods, count and index. These methods only read information from the tuple. They never change it. The count method first. The count method tells how many times a particular value appears inside a tuple. The syntax of a count method is this. Example of tuple count method. Print numbers dot count. The output is 3. Let's understand why. Our tuple is 1, 2, 3, 2, 2. Now count how many times 2 appears. First occurrence, second occurrence, third occurrence. Total equal to 3. So Python prints 3. Let's see another example with fruits list. This. That run the code. It will also print 3. क्योंकि again apple appears 3 times. Here, here and here. This method is very useful when checking duplicate values. For example, how many students scored 100, how many times yes appears in survey data, how many repeated in entries exist. Instead of creating a loop, count gives the answer in one line. Index method. Second. Now learn the second method index. The index method tells us the position index of an element inside a tuple. Syntax of an index method is this. Example, numbers is equal to 5, 10, 15. Then number index equal to 10. If I run this code, the output is 1. The output is 1. Let's understand why. Our tuple looks like this. 0 equal to 5, 1 equal to 10, and 2 equal to 10, 15. Since 10 is present at index 1, Python prints 1. Let's see another example of color list, color tuple. This is the color tuple. If I write a print colors dot index blue and then run the code, it will print 2. It will print 2 because blue is stored at index number 2. Important note, if the value is not present in the topic, Python gives an error. Like I am writing numbers 10, 20, 30, then print number dot index equal to 50. Then run this code. It will Python gives an value error. This happens become because 50 does not exist in the tuple. So before using index function, make sure the value is actually present. Tuple packing. Tuple packing. Packing means putting multiple values into one tuple automatically. The best part is that how you don't even need parentheses. Example, student Rahul, 20 Delhi. Print student. Output is in tuple. When I run this code, oh, it will notice something interesting. We never wrote parentheses, yet Python automatically created a tuple. This process is called tuple packing. Python packs multiple values together into a single tuple. You can think of it like packing different items into one bag. For example, name, age, city, all of these are packed together into one tuple called student. Packing is commonly used when returning multiple values from a function. We will see that in later videos. Now suppose we already have a tuple. Can we separate each values into different variables? Yes, the process is called tuple unpacking. If I write here like this, this, then I print name, city, and oh sorry, city and age. When we run this code, it will print Rahul 20 Delhi. The tuple contains three values. Rahul 20 Delhi. Python automatically assign Rahul equal to 20, Rahul equal to name, 20 equal to age, and Delhi equal to city. Now each variable stores one value. You can use them individually. Print name prints only Rahul, print age prints only 20, print city prints only Delhi. This saves a lot of coding. Instead of writing name equal to student and indexing 0, age equal to student indexing 1, age city equal to student indexing 2, we can do everything in one line name, comma age, comma city equal to student. This is cleaner, shorter, and more Pythonic. The number of variables must match the number of values in the tuple. For example, I am writing here Rahul 20 Delhi. Name and age equal to student. Pi- and I can't, I am not writing here city and it is this also. And when we run this code, Python will give an error because there are three values but only two values, two variables. Always remember three values, three variables. Four values, four variables. Now let's move to another very important Python data structure called set. It is all of this right here set. Hmm. Now let's move to another very important Python data structure called set. Till now we have learned two collection list tuples. Now the question is what if you want to store data where duplicate values are not allowed? For example, student roll number, register email ID, unique username, unique product ID. In these situations, duplicate values don't make sense. To solve this problem, Python provides sets. What is a set? A set is an unordered collection of unique values. I write in notes section. There are three important things to remember about sets. First, unique values. A set never stores duplicate values. If duplicate values are provided, Python automatically removes them. Second, unordered collection. Unlike list and tuple sets, do not maintain the order of elements. That means the output. may appear in a different order every time. So never expect the first element to remain first. Third is create using curly braces. Sets are created using curly braces. Example like this. When we run this code, it will give a curly brace. Notice something interesting. We inserted apple, banana, orange, but Python printed them in another order. This is completely normal because sets are unordered. The order is not guaranteed. But one of the biggest advantages of sets is that they automatically remove duplicate values. Duplicate removal. Duplicate remover. One of the biggest advantages of sets is that they automatically remove duplicate values. If I write here this numbers equal to 1, 2, 3, 3, 4, 5, 5. If I print number, then run the code, it will print 1, 2, 3, 4, 5. Let's understand what happened. Initially, we inserted this. Notice that 3 appeared twice, 5 appeared twice. Python automatically removed the duplicate values. The final set becomes 1, 2, 3, 4, 5. This feature makes sets extremely useful when cleaning data. Imagine you have thousands of repeated small addresses or phone numbers. Instead of writing complicated code, you simply convert them into a set and duplicates disappear automatically. Avoiding elements and adding elements. Adding elements using add function. For this, Python provides the add method. Like I write here fruit, apple, banana, orange. If I write here fruits dot add mango and then run the output, the answer is mango, orange, apple, banana. Notice that mango has been added. Again, don't expect any particular order because sets are unordered. What if we add an existing value? If I write here fruits dot add apple, then run the code. Will apple be added again? No. The output remains exactly the same because sets never allow duplicate values. This is another reason why sets are perfect for storing unique information. To remove an element, we use the remove method. Remove element. Like I write here fruits dot remove apple, then print it. Apple is removed. Our set gives us mango, banana, orange after removal. Important point. What happens if apple is not present? Uh, Apple is not present. Again, here. Python gives an error, usually key error. Oh, sorry. Then run the code. Python don't give an error. So removes should be used when you are sure that the element is present. Oh. Wait. Here, then we run the code. Python will give an key error because the element does not exist. So remove should only be used when you are sure that the Python element is present. Python gives us a safer alternative called discard. Discard. Safer alternative of remove elements. If I write here pyproof.discard grabs, then run the code. Suppose grabs does not exist. Will Python show an error? No, nothing happens. The program continues normally. This makes discard much safer than remove. Difference between removes and discard is remove gives an error if the value does not exist. Discard does not nothing if the value does nothing if the value does not exist. No error is generated. I write in the notes section also here. Whenever you are unsure whether an element exists, prefer using discard. Now let's learn about pop function. If I write here fruits.pop, here mango, orange, banana is present already. This remove one random element. Let's check which element is removed. Mango, orange, banana. Orange is removed. Notice that what random in list pop removes the last element, but in sets there is no first or last element because sets are unordered. So Python removes any random element. Suppose I am showing you like mango, orange, and banana is already exist. If I write pop here, then orange is removed automatically. It depends on Python internal implementation. Never use pop if you need to remove a specific element. For that, you always use remove or discard. Then move to clear method. Sometimes we want to delete every element from a set. Instead of removing element one by one, Python provides the clear method. If I write here proofs.clear, the output is set and null set. The set still exists, only its contents are removed. This of think of it like an empty box. This box is still there, but everything inside it has been taken out. Now that we know that what sets are and how to add or remove elements, let's explore one of the biggest advantages of using sets operations. Sets operations come from mathematics. If you have studied unions, intersections in schools, you will notice that Python uses the same concept. These operations are widely used in real-world applications such as finding common students between two classes, identifying duplicate users, comparing customers list, finding unique products, data analysis, and machine learning. Python provides powerful operators to perform these operations in just one line. For today's lesson, we will use two sets. One A, 1, 2, 3, B, 3, 4, 5. First, comment out all of this. A, 1, 2, 3, and B, 3, 4, 5. Let's understand each operation one by one. The first operation is union. What is union? Union. Union combines all unique elements from both sets into new set. If value appears in both sets, Python keeps only one copy because sets never allow duplicates. If I write here print A union B, then the output is 1, 2, 3, 4, 5. Let's understand how Python gets this answer. Set A contains 1, 2, 3, set B contains 3, 4, 5. Now combine both 1, 2, 3, 3, 4, 5. Since set does not allow duplicates, 1, 3 is removed automatically. Finally, answer becomes 1, 2, 3, 4, 5. Imagine two classes. Class A, Rahul, Aman, Priya. Class B, Priya, Neha, Rohan. Union means all students from both classes. Result, Rahul, Aman, Priya, Neha, Rohan. Notice that Priya appears only once. This is exactly how the union operations work. Now let's learn intersection. Intersection. Intersection returns only the common elements present in both sets. Example, print A intersection B. Then run the code. The answer is 3. Why? Let's compare both sets. Set A 1, 2, 3, set B 3, 4, 5. Which number exists in both? Only 3. Therefore, the output is 3. Suppose two cricket teams have selected players for training. Team A Rahul Aman Virat, Team B Virat Rohit Hardik. Intersection gives the players common to both teams. Virat. Intersection is frequently used to find common records between two datasets. And third is difference. Difference returns elements that are present in the first set but not in the second set. If I write here print A minus B, the output is 1, 2. Let's understand. Set A equal to 1, 2, 3, set B equal to 3, 4, 5. Now remove everything from set A that also exists in set B. The number 3 is common, so remove it. Remaining elements are 1, 2. Hence, the output is 1, 2. Important point difference is directional phase. If we reverse the sets, like I write here, print B minus A, the output will be 4, 5. Because now we are removing the common elements from set B. Suppose student who registered for a course, Rahul Aman Priya. Student who actually need attendance, Priya. Difference gives student who registered but did not attend. Result Rahul Aman. This is very useful in attendance system. Now let's learn the last and most interesting operations, symmetric difference. Symmetric difference. These operations returns elements that are present in either set but not in both. In simple words, it removes that the common element and keeps only the unique ones. If I write here this and print it, it will print 1, 2, 4, 5. Let's understand it step by step. Step A. Set A 1, 2, 3. Set B 3, 4, 5. Common element 3. Remove the common value. Now the only unique value remain 1, 2, 4, 5. Hence 1, 2, 4, 5. Imagine two music playlists. Playlist A song 1, 2, 3. Playlist B song 3, 4, 5. Symmetric difference gives a songs that appears in only one playlist. Result song 1, 2, 4, 5. The common song is removed. Now we have reached one of the most important topic in Python, the dictionary. Now, if you ask experienced Python developers which data structure they are used most, many of them will answer dictionary. Why? Because dictionaries make it easy to store, search, update, and organize data using meaningful names instead of index numbers. List and tuples store values using positions indexes, but dictionaries store data using keys. This makes program much easier to understand and write. A dictionary is a collection of data stored in the form of key-value pairs. Every piece of information has two parts: key, the name or identifier; value, the actual information. Think about a real-life dictionary. If you search for the word Python, you get its meaning. Here, word equal to key and meaning equal to value. Python dictionary work in the same way. Instead of searching the by index number, we search using keys. Dictionary syntax. Dictionary are created by using curly braces. Like remove this. This is the dictionary. If I write here print student, then run the code. Let's understand this dictionary. Name equal to Rahul, age equal to key में na- in key name age city. Well, in value Rahul 20 Delhi. Name equal to Rahul, age equal to 20, city equal to Delhi. Notice that every key is connected to one value. This is why dictionary is called key value collection. Now suppose we only want Rahul names. Do we use indexes? No. We use the key. We use the key here. Like I write print student name and then run the code. It will print Rahul. Python searches for the key name and returns its values. Similarly, if I write here name, if I write here age, then run the code, it will print 20. Unlike list, we don't remember index number. We simply remember the key. This makes dictionary much easier to work with when storing real world data. What if we want to store one more pieces of information? For example, the student marks. Adding a new key is very simple. I write here student marks equal to 95. Now if we print the dictionary, the the output in output the marks is added, marks 95. Python automatically creates a new key called marks and stores the value 95. No special method is required, just write a key and assign a value. Now suppose Rahul had a birthday. His age changes from 20 to 21. Updating a dictionary is also very easy. If I write there student age equal to 21, now print the dictionary. Age converts from 20 to 21. Python simply replaces the old value with the new one. This is one of the biggest advantages of dictionary. You can easily update information whenever needed. Sometimes we need to data, remove unnecessary information. For example, suppose we no longer want to store the student city. We can delete it using the del keyword. I write there del student city. Now print the dictionary. Notice that only the city key has been removed. The rest of the dictionary remains unchanged. Now let's learn how to loop every key and a value stored in a dictionary. For this, Python provides the items method. For key value in student.items, it will print. First, stop this printing and remove this. Then run this code. Python prints name Rahul age 21 marks 95. Let's understand what's happening. The item method returns both the key and its corresponding value. During each loop, Python stores the key inside the variable key, the value inside the variable value. First iteration key equal to name value equal to Rahul. Second iteration key is equal to age value is equal to 21. Third iteration key equal to marks value is equal to 91. This is the easiest way to display all dictionary data. You don't need to access every key manually. Imagine a student record. Instead of writing separate print statements like student name, student age, student marks, a loop prints everything automatically even if the dictionary contains hundreds of keys. That's why loops with dictionaries are used extensively in real applications. Now that you have learned how to create, access, update, and delete dictionary data, let's explore some of the most useful dictionary methods. Let's just like list have methods just as append and remove, such as append and remove. Dictionaries also have built-in methods that makes working with data much easier. Today we will learn these important methods. Here I write keys, function, values, function, items, get, pop, update, clear. These methods are used almost every day in Python programming, so make sure you understand them well. Well, use the following dictionary throughout this section. Name equal to Rahul, age equal to 20, and city equal to Delhi, and marks equal to 95. Let's start with the keys function method. What does keys do? It returns all the keys present in the dictionary. Like I write here, print student dot keys. Then run the code. The answer is name, age, marks. Notice that only the key names are displayed. The values are not shown. Imagine a student admission form. The field names, name, age, marks are the keys. The actual information entered by the student is stored as the values. Sometimes we only need the field names and keys gives them instantly. Value method. Now let's learn value method. What does value method do? It returns all the values stored in the dictionary. Like I write here, print student dot values like that, and then run the code. It will print the value, all the values stored in this dictionary. This time Python displays Rahul 2195. Only the values are written. This is useful when you don't need the keys and only want the stored information. Now let's learn item. What does items method do? It returns both the keys and values together. If I write there print.student.items method, run the code. It will print like that. Notice that every item appears as a pair. Name Rahul, age 21, marks 95. This method is extremely useful when using loops. That's why earlier we wrote for key value in student.items. This line, print key value, it gives both pieces of information together. Now let's learn about one of the safest dictionary method, get method. The get method returns the value of a given key. If I write here get method, then I run the code, it will print 21. Age is 20, but I convert it to 21. The age is 21. It will give the answer 21. Python searches for the key age and returns its values. Why use get method instead of square brackets? Suppose we write print student phone. If phone does not exist, Python gives an error. But if we write student.get phone, output is known. No error occurs. This makes get much safer, especially when you are not sure whether a key exists. Now let's learn pop method. The pop method removes the key and returns its values. Student.pop marks and then print students. Run the code. The output is name Rahul age 21. The mask key has been removed. Important rule. Unlike delete, pop method also returns that the remove value if you store it in a variable. Like I write here remove and then print remove and then run the code. What happened? Hmm. It will print 95. This is useful when you needed the deleted value later. Now let's learn update method. This method is used to add new key value pairs to update existing ones. Like I am writing the student.update course Python. Now print the dictionary, print student. This is shown. The Python automatically added a new key called course, updating existing data. Suppose we write student.update age 22. Instead of creating another age key, Python updates the existing value. So update method can perform both tasks. Add new information, update an information, update old information. Finally, let's learn clear method. Sometimes we want remove every item from a dictionary. Instead of deleting each key one by one, Python provides the clear method. Student.clear, print student. The output is only curly braces. The dictionary will exist. It's simply empty. Think of it like deleting everything from a notebook while keeping the notebook itself. So far, we have learned how dictionary works and explored their important methods. Now it's time to use dictionaries in real programs. The best way to learning programming is by solving practical problems. In this section, we will build two simple applications, Student Information System and Phone Book Search. This program will help you understand how dictionaries are actually used in real-world software. First program, Student Information System. Imagine you are creating a small application to store a student detail. Instead of creating separate variable for name, age, and marks, we can store everything inside a dictionary. Let's see the program. First, I create an empty dictionary, then student name, student age, then print student. Step 1. Here we create an empty dictionary. At this moment, it contains no data. Step 2. Student name. Python asks the user to enter the student's name. Suppose the user enters the Rahul. The dictionary becomes name Rahul. Step 2. Student age. Now Python asks for age. Suppose the user enters 20. The dictionary becomes name Rahul age 20. Then press enter. Now that we use int because age should be stored as a number, not as text. Student marks. Suppose the user enters 95. Now the dictionary becomes name equal to Rahul, age equal to 20, marks equal to 95. Finally, print student. It will print the data. Congratulations, you have just created a small student database using a dictionary. Real life applications. This same concept is used in a school management system, college admission software, employer records, customer information system, online registration form. Instead of storing only three pieces of information, real applications may store hundreds of details in dictionaries. The program 2 is phone book application. Phone book application. Now let's create another practical project. Suppose you want to build a simple phone directory. Instead of searching through a list, dictionary allows us to find phone numbers instantly using name as key. First I create one phone book like this, and name print phone dot get name or not. Let's understand each step. We create a dictionary phone Rahul and Amit with numbers. Rahul has this number and Amit has this number. The names are the keys and the phone numbers are the values. And step two, Python asks the user to enter a name. Suppose the user types Rahul. User types Rahul and print phone.get. If the get method searches for the entered name, if the name exists, Python prints the phone number output. Now suppose the user enters Sangam. Since Sangam is not present in the dictionary, the get method returns the default value, not found. This is why set get is safer than using square brackets. It prevents your program from crashing when a key does not exist. This concept is used in mobile contact app, employee directories, customers databases, hospital patients records, online search systems. Whenever you search using a unique identifier like a name ID or username dictionaries are one of the best choices. Now, this it's time for a very popular and a practical Python program, the frequency counter. This is one of the most common interview questions for beginners because it combines several important concepts you have already learned: loops, dictionaries, dictionary method, user input. In this project, we will count how many times each character appears in the given text. Frequency counter program. Frequency counter program. Let's write the program first. I write text input first, then frequency curly braces for character in text, frequency counter plus one, and then print frequency. Let's understand it line by line. Here Python asks the user to enter some text. For example, user enters Python. This entire word is stored inside the variable text. Frequency. We create an empty dictionary named freq. This dictionary will store key character value number of times that character appears. Initially empty dictionary, the dictionary is completely empty. For character in text, this loop reads one character at a time from the enter text. If the input is Python, the loop runs like this. First loop T, second loop Y, third loop T, fourth loop H, fifth loop O, and sixth loop N. Each character is stored in variable ch. Step 4. Count the character. Now comes the most important line of the program. Frequency ch dot get ch comma 0 plus 1. Let's understand it carefully. The get method checks whether the character already exists in the dictionary. If the character is already present, it returns its current count. If the character is not present, it returns the default value 0. The Python adds one and stores the updated count back into the dictionary. The single line handles both situations, creating a new character entry, updating the count of an existing character. This is very common Python programming technique. Suppose the user enters Python. Every character appears only once, so the dictionary becomes P4, Y1, T1, H1, O1, N1. Suppose user enters banana, then B1, A3, and 2 times. Notice that the program automatically counted repeated character without writing a separate code for each letter. That's the power of dictionaries. In the last, I am giving you some homework question. You have to solve by yours. You have to try to solve by yourself. I am giving you 8 homework questions here. First homework is create a tuple containing 5 subjects. Second is find the maximum value in a tuple. Question number 3, removes duplicate numbers from a list using a set. Question number 4, find the union and intersection of two sets. Question number 5, create a dictionary of 5 students with marks. Question number 6, search a student using the dictionary. Question number 7, count the frequency of each word in a sentence. Question number 8, create a student database where user can add student, update marks, search student, delete student, and display all students. Tuple summary. We studied tuple methods, packing and unpacking, set methods, set operations, dictionary methods, dictionary program, frequency counter, and student database mini project. Congratulations, you have successfully completed day 9 of our Python complete series. Today we'll learn some of the most important Python data structures, tuple set, dictionary set operation, dictionary method, frequency counter project, and student database mini project. If you have understood today's concept, you are now able to organize and manage data much more efficiently in Python. Now it's your turn. Complete all the homework questions and try to build the student database project on your own without looking at the code. That's the best way to improve your programming skills. If you found this video helpful, don't forget to like the video, comment your favorite topic from today's class, subscribe to the channel, and turn on the notification bell so you can never miss the next lesson. In day 10, we will move to one of the most exciting topics in Python, file handling. You will learn how to create files, read data, write data, append content, work with CSV files, and build real world file based projects. Thank you so much for watching and supporting this series. Keep practicing, keep coding, and remember the more you code, the more confident you become. I will see you in the next video. Until then, happy coding. Goodbye.